Okay, so now we're going to look at a couple different ways to create landforms in Rhino. This can be from the traditional kind of approach of having a series of flat contour lines that you just need to manually move up whatever their intervals or height is. Then I'll also show you some more advanced ways by using a couple different plugins for Grasshopper, and I'll go over how to actually get those set up as well. But at first I just want to show you how, if you want to go through this process where you just don't have access to shape files or other files that have their heights already figured out, I'll go through that process as well as how do you start to actually create some type of 3D geometry from that. So it could be a mesh, it could be a surface. Um, those are kind of to your discretion, and it's important to consider too when you get into the analysis of these landforms too. So again, this is just kind of a very kind of laborious process of just taking them and shifting them all up. So I'm just going to select all but the lowest one, hit M for move, V for vertical, and I'm going to say that these go up 2 feet. So I'm just going to hit 2, deselect by holding Control to go to the next one, hit spacebar to repeat that command, hit V again, 2. And so again, this is just going to be a little tedious at first. Obviously, there might just not be those circumstances where you can get out of this, but it's still important to do in some cases. So, oops, let's keep that one and do that one. Move, V, vertical. Only a couple more. Last one. Alright, so you can see we start to create this kind of mound here from these contour lines. So there's a couple ways you can do it just in Rhino. Again, take advantage of a Grasshopper to give yourself a little more control over the density and quality of these surfaces. That's what's really important by going through this process. So again, I'm going to select these curves, reference them in Grasshopper. And you might think that you can just kind of join these curves to create a surface. I honestly prefer going through using points instead. So basically telling all these curves to have a certain density of points, and from there we can start to create the 3D geometry. I don't usually recommend one of the common ways to create surfaces from curves or to loft them. It's not exactly the best option in many cases. It could look very jagged, and you could just easily see the seams between these contours. So there's a couple other better ways. So I'm going to take these curves. I'm going to divide them, or I could use the distance. Sometimes it's good to do it by distance. That way, areas that are smaller, they aren't going to have the same amount of points as some of these large ones, where this could either be less dense than this because they're trying to pack in just as many points, or vice versa. So sometimes it's good to just do it by distance. So let's try doing it every 5 feet for now. Let's see what that point density looks like. So it's pretty reasonable. I think you can start to get some pretty high resolution, and if I begin to reduce this, I can start to get that even higher. So let's not do it to 0, but let's just see what happens around 2. So again, that's a pretty dense point cloud for now for these contours. And remember, as your landforms become more advanced, it's going to take up more memory and can start to lag your computer the more you're having to process. So we'll just start off with something for now. And again, these are kind of each group of points is on its own branch of data, so it's good in this case to actually flatten this so they're all treated in that one single pool of data. So from here, this is where we can start to create the geometry. So I'll start off by just going to our mesh, and we did it a little bit before, but you can use the Delaney mesh. This essentially starts to triangulate it using these points. So I'll just drag that in. We can turn this off just to see what that starts to look like. It looks pretty smooth already. I mean, I can even bake this to get a better idea of what that looks like as well. Let's go to shaded to see what that looks like. Or we can even render it to see it a little bit better. So not a bad looking landform. You can't really see that triangulation that's occurring when I select it. To correct some of those areas where it almost is flat at the top, we can, let's go back to shaded. What I can also do is add a point to this as well. So maybe I want to look at it from above. Maybe I'll put 2 points to give it kind of like a saddle. So I'll select those 2 points, go to perspective, and I'll just make sure that they're slightly higher. So maybe one's a little bit higher than the other. And now I can reference those points as well. Hit enter. And now I'll actually hold shift to join that. And now we can start to see how that creates these values. And what's kind of cool about this too is I can always, again, kind of select these to move them up. It's not creating the most desirable kind of saddle, but you get the point. The more points you add, the better it'll look. And obviously, let's just get rid of those for now. If I start to decrease the density of points by doing them over further distance, we can start to see that the resolution will start to change. So again, let's just kind of see what that looks like in comparison. So again, you can see this has a lot less triangles in it versus if I do it around 2, bake it, it starts to get a little bit smoother, right? So you can start to see that you kind of lose a lot of that resolution in this one compared to this one. It's slightly more detailed, which is nice. So that's one way. Again, those are creating a mesh, which is a little bit more difficult to edit, but I'll show you how to correct that as well. I'm just going to go ahead and delete these because they might start to mess with the next step. So that's one way to do it. It's pretty simple, which is great. Another way is I can use, again, the same kind of density of points and go to surface instead, go to freeform, and use the patch component. So it's asking for either curves or points. The curves and points are pretty much going to do the same thing. I honestly prefer to use the points. You can change, this is essentially going to create or affect the detail that's happening between those points. The higher the number, the more detailed it'll look. Flexibility, usually don't have to worry about that too much. And the trim rarely happens. I like to just do that manually. So let's just see what happens when I plug this up. You'll see that it kind of does this weird interpolation once it goes beyond, because it's essentially going to try to create a rectangular surface. So that's why if I go to the top, it almost looks like a square. It's just kind of going beyond those limits, and that's what I'm saying, where you need to actually trim those manually. And you can just use the lower contour here. But again, you'll see that what happens when this is at a span of 20. Let's go ahead and bake it. You can see instead of it being triangulated, it's actually made up of a grid. It definitely looks much smoother than the mesh. And let's see what happens if our number of spans jumps up to 50. Hopefully my laptop can handle that. It's not that crazy. Actually, it looks like it did it pretty well. So let's just live a little and jump up to 100 and see what that does. So this is starting to kick the laptop into overdrive a little. I think this always happens to me where I do really well with a span of 50 and then I just say, you know what, let's just go ahead and jump up to 100 and then it takes forever. So unless you have a really powerful computer, I don't recommend going up that high. 50 seemed like it was pretty reasonable, and I'm sure there's probably not going to be that much of a difference. Right, so we can start to see just how dense that grid of points are in comparison. So it definitely captures a lot more detail that's happening, right? I can see this profile is a little bit more defined versus this one almost seems very uniform. And again, when we start to render, we can definitely see a distinct difference between the two. So it does make a difference. Just so be aware of it though, that the more information you're processing, the longer it starts to take. However, it's really kind of up to you. But like I said, in order to just get rid of that, I'll bake it one more time and just keep it in place. Hit OK. Then I'll turn this off. Go back to shaded. And I'll just make sure I'll basically just take whatever that lowest contour is. I'm going to project onto a surface, so just the project command, delete input, no. Doesn't really matter what the output layer is. Then I'm just going to select this as the surface I want to project it onto. They should pretty much stay the same. And then I'm just going to make sure that I actually cut through it. So I'm going to extrude this curve. And I'm going to make sure to do it in both directions. And I'm basically going to use this as a way to trim away all that excess surface. So I can take this. I'm just going to split it because splitting usually works a little bit faster, and then I just delete that part. Select cutting object, so this is what I'm using to cut. And hopefully it looks like it works. I can just delete that, delete this. And now I have a nice trimmed surface. Awesome. So there, now you have a nice surface versus the mesh. So let's go back, and I'll keep this around just to show a comparison. Let's go back to this mesh. Let's go ahead and bake it as well. Because like I said, and you can see that there's even some kind of excess. I'm not going to worry about that too much right now. So you already saw how you can trim that away. But I want to show you that this is a little bit more difficult to edit. Usually with things like surfaces and B-Rept, you have a lot more editing capabilities versus mesh. Meshes don't usually like to be edited. So in this case, I want to convert this to a surface, respectively. So what I'm going to do, there is a command where you can convert a mesh to a surface, but I'm actually going to use a different command. I'm going to use the drape command, drape surface over objects. In order for this to work well, it's good to go on the top view. And similar to the patch having these spans, the spacing is very similar. It's, instead of it being a high number for a denser, you actually want the spacing to be lower, I believe. So let's try a spacing of 2. Then I'm just gonna do what it says, so drag over it. And you can see that it's actually creating a pretty dense grid of points. So I want to say those spans are basically almost every 2 feet. But we can start to see how that looks in comparison to the other mesh or the other surface that we made, right? It doesn't always look that great. So I do prefer to kind of, in some circumstances, create a surface using the patch tool. This, obviously, the more you begin to tweak it, the better it can look. But this is, I think, good just to start to see how these start to differ from each other. So I'm going to shift gears a little. So this was showing, again, kind of the laborious process of creating landforms from these planar contour curves. But again, this is a very simple one. It wasn't that difficult to create that landform. But what if you want to deal with something that's much more complex? So I've also got QGIS turned on right now, and this is just an open source platform that's basically works like GIS. It's not as powerful and you can't do nearly as much. However, for the things that I like to do, it works great. And you can see that I'm looking at this gigantic contour map of the Las Vegas Valley area. But I want to actually start to create a 3D landform from something like here, where there's a lot of different things going on. This would just take a very long time to actually physically lift up, and especially since you have various ridges and mountain ranges, requires multiple contours to be at the same level, so it's not just about going from one to the other. It does require a lot of effort to make sure that those are accurate. So I'll show you how to begin doing that, because I think this is a much more useful tool. And I'm going to use a plugin inside of Grasshopper to help with that as well. So you can see that when I zoom out, this is a pretty big file of just 20-foot contours. If I try to just bring this right into Grasshopper, it's really going to have a fit. So I'm actually going to create a clipped layer that's just going to look at a portion of this. And hopefully what I create a clipping box around will be enough for it to handle. It should. It's pretty effective plugin, but I really kind of like this area because of all the ridge lines and washes that are kind of cutting through this. It should be a really interesting model to look at. And what's good too is that this shape file also has the designated elevation of these contours, so we can immediately use this metadata to assign those elevation of the contours, which you'll see in a moment. So let's go ahead and do that. So I'm going to create a new layer. So layer, new shapefile layer. I want this to be a polygon layer. Let me just check. Let's just make sure that we're using the same coordinate reference system. So you basically want to make sure both layers are using that same reference system, else things won't match up. So I can remember that this one has a very obscure name versus all the other standard ones, so we'll just remember that. We can actually set the project to have that coordinate system as well. So that is also going to help. So let's go ahead and again, layer, create layer, new shapefile layer. Now we know to make sure to use the project one. Hit OK. And it's going to ask for a destination to save us. So I'm just going to call this bounding box. Hit OK. Now I'm going to turn on this pencil to create one. And then I'll just go to Edit, and then Add Feature. And I'm just going to create as close to a rectangle as possible. And I'm just left clicking as I'm going about. Again, I'm kind of taking a gamble because I haven't tried this large of an area or this complex of an area, but it could be cool. And again, it doesn't have to be perfectly rectangular. And then once you're done, you can just right click, hit OK. Now you've got your bounding box. I'm going to turn that off and save it. And now I'm going to create that clipping area. So all I have to do is go to Vector, Geoprocessing Tools, and Clip. So it's asking what's the layer that you're clipping. In this case, it's my contours. The clipping layer is that bounding box. And we'll just create our temporary layer. Hit yes. I thought these were both using the same coordinate system, but... okay, so it still worked. So let's just go ahead and turn off all of this. So here's our new clipped contours. This should be a lot more manageable, and even though you've clipped it and it's creating a new layer, it's still going to keep that metadata. So now I'm going to go ahead and save it. Call this clipped contours 20 feet. Okay. So it's again just going to kind of create a duplicate of that, but that should be okay. So now I'm going to go back over to Grasshopper, and I'll put the link to this plugin and how to download it in the video. But what it's called is Add It, and this gives you the ability to import a shapefile, keeping it scaled and bringing in all those features. So I'm going to really just use two plugins, two of these components. So what it's asking for is the file path. So where is that shapefile that you want to bring in? So I'll go back to Parameters, File Path, bring that in, right click, Set One File Path. I'll go to the file where I saved it, so I'm looking for this AutoCAD shape source. It's going to give you a lot of different files. Good rule of thumb is the largest file type is the one you're going to use. So I'm going to plug this T into this S value. And then I'm going to also look at the different features. So like I said, there's a lot of different metadata. The ones I'm more interested in is the contour feature. So if I look, the contour is list item 7. So what I want to do is go to Sets and choose that list item. So I can use this to manually kind of filter out all that and enter 7. Now you'll see that I've got my contour as the list item, plug that into get value feature, and then in order for it to run it, I need to get a Boolean to plug into here. So I'm going to go back to parameters, choose the Boolean toggle, plug that into there, and hit true. Oops, I think I grabbed the wrong one. Let's go back to Edit, Shape. Let's do the import one actually. So that's usually a good rule of thumb. I don't know why. It's the T into the S. That's usually the issue. But let's go ahead and plug this. But everything else should stay the same. This F is going to the list item. And this also needs the true and false. And I knew that was missing. So I should have known from the start that that was the wrong component. But anyways, from this, it's looking at is there polygons. In this case, they're actually considered polylines. There's no points, but then there's the values, which are in fact those contour elevations, right? So I have this and I have my polyline. So I can basically associate all those elevations with those curves. And you can see that there's a couple different values and then a couple different lines. So what we're going to do is and this does actually place it in its respective geolocation, which can be a little bit difficult to find. So I'm just going to go ahead and hide these for now, so that way when I run this, I should be able to find it a little bit better. So let's see what happens when I zoom out, see if we can find it. So looks like it's nowhere in sight. Let's we could bake it right now, but could be an issue. Huh. Maybe if I take these curves to try and see where these points are. Sometimes those are, there it is. So it's a little bit easier to see it that way. These X's that represent the points are a little bit easier to see the curve, so it's way over there. So let's just kind of keep zooming in until we find it. I promise it'll be all worth it once we get there finally. Come on. Sometimes you have to recalibrate this zoom in order to see it a little bit better. There we go. So now we can go ahead and just turn this off. And so there you can see it's identical to what we just exported from QGIS, but you'll see it is perfectly flat. And we obviously do not want to have to manually do that. So that's why we're using this plugin to give us that ability. So basically what I'm going to do is tell those lines to move in the Z direction based off of their values. So let's do Z. Now I can just go ahead and plug that into there. Let's turn all this stuff off. And there's our beautiful topography with the contour lines. And you can do the same thing as we did before. We can take all these curves and this is to scale, so we probably don't want to give it something like 2 feet. Let's try something at first like 100 feet. That's probably still going to be a lot of points, as you can see. So from here I can again just go ahead and flatten this. For the purposes, because I know the patch is going to take a while, but that is something just like how we showed earlier. I'll plug that into there. Preview. Preview. And here's our mesh terrain. Looks pretty cool. Oops, why is it doing that? Oh. Looks even better when it's rendered. So again, it's a pretty cool way to pretty quickly create these mesh landforms using this plugin. And again, I'll show you on the video. I'll provide the link so that you can get to that plugin as well.